Hello, my name is Rachel Girard, and I'm here today to talk about my thesis. My thesis focuses on method development, specifically the development of a liquid chromatography, post-column derivatization, atmospheric pressure, chemical ionization, tandem mass spectrometry method for the vitamin D analysis. Now that is quite the mouthful, but first, why vitamin D? Now, vitamin D isn't exactly new. In 1922, Dr. Elmer McCollum discovered a substance in cod liver oil with anti-ricketic properties. Anti-ricketic meaning it can prevent or cure rickets. He would name this substance vitamin D. The structures of the two primary forms of vitamin D2 and D3, were determined during the 1930s and then mass-produced in order to fortify food and drink, leading to the near global eradication of rickets. However, the first tests to measure vitamin D sufficiency were not invented until the late 1960s. Since then, improving existing methods and developing new methods is an ongoing effort as vitamin D insufficiency continues to be linked to certain health complications like long COVID. Liquid chromatography mass spectrometry methods are the gold standard for measuring vitamin D status because of the selectivity and sensitivity they offer. Liquid chromatography separates a sample into its individual components based on their respective polarities using a chromatographic column. Following separation, nonpolar vitamin D elutes into the mixing tea of the atmospheric pressure chemical ionization, or APCI source. The APCI source will evaporate the solvent and ionize the now gaseous molecule. To improve the ionization of vitamin D, it needs to be derivatized. The derivatization reagent I chose is a dienophile called 4-phenyl-1,2,4-triazolene 3,5-dione, or PTAD for short. Because vitamin D has a cis diene highlighted in blue below, in its structure, which not many molecules have, PTAD will only react with the vitamin D. Normally, in solution, this reaction takes about an hour, but in the gas phase, this reaction takes milliseconds. During my time here at Villanova, I have been evaluating the efficacy and accuracy of my post-column derivatization. To my knowledge, there are no other post-column derivatization methods cited in the literature, making this aspect unique. Through a series of experiments, I have been able to optimize the instrument and compound parameters to improve the signal and lower my limit of detection. While my percent conversion for the PTAD adduct is under 30%, I can reliably detect concentrations as low as 10 parts per billion, which, to put in perspective, if you have a 25-hydroxy-D measurement that is of less than 10 parts per billion, it's a sign that you have severe vitamin D deficiency. Currently, I've applied my method to several oral supplements and powdered beverage mixes, and I continue to try and improve my extraction process to better evaluate my method's accuracy. Thank you for your time today.